If you could find the area of this triangle, that would be nothing but multiplying these two, then divide by 2 to a number. Then you're saying, this is a number, then you would find what A and B are. So I think finding the area of triangle is the key. So that's how you should approach this problem. And then, well, you can approach it, but how do we go about it? How do you find the area of this triangle when all they gave you is not the sides, but all the things are inside? Turns out there's no simple way of doing this, although it's very tempting. This point is uniquely determined because it's distance of 7 and 6 and 11 from 3. There's famous name for this. It's called triangulation. But the thing is, yes, this point is uniquely determined, but finding the distance is no trivial matter. So you can use systems of equations, You can solve this, where they are. Using A and B, you can find the equation of this line, equation of that line, and you can see the intersection. But it gets enormously complicated. This is problem 23, but that's too time consuming. It's not fitting for the math competition. There's got to be an easier way to crack this. And there is. So I'd like to show you. Instead of finding the area of this triangle here, we will double the size of the triangle so that the area will be just this times that without dividing by 2, because we will double the triangle. But we will not go to make a square because that doesn't help us any. We cannot find the area of that square either. So what we do is this. We make it mirror image like that, and this would be 7, right? This would be 11. Now, I don't know what this angle was, but it is equal to that angle. You agree? And I don't know what this angle was, but that would be equal to that angle. And this is hypotenuse, so it's just nothing but the side times root 2, which I do not bother to write because this is not useful. And then now I'm going to take this triangle and fold it to the left as a mirror image, and I get something like that. So that would give me 7 here, then give me 6 here. Would you agree that this angle is equal to that angle? Okay. And you know what I'm going to do? I'm going to unfold this one too. So here we go. Then you say this is 6, right? Because 6 got mirrored here. 11 got mirrored here. And you would say that I didn't do it here, but let's do it. This angle is equal to that angle, although we don't know what it is. And this angle is equal to that angle. And I'm running out of symbols here. Is equal to that angle. Okay, we got that. Now, what do we know? This original white triangle inside here, it was an isosceles right triangle. It was a right triangle. So this 2 ticks and a circle tick added was 90 degrees. So the entire thing should be twice that, right? Because tick got doubled, the double tick got doubled, and this circle tick got doubled. So 90 degree got duplicated, so it's 180 degrees. So this is straight line. Okay, that much we know. So I don't have to show you. All we care is that it is a straight line. What about here? This was 45 degrees internally, right? Some part of it got duplicated and the remaining part got duplicated. So together it became 90 degrees. So this is a 90 degree angle. Now look at this white triangle here. Double angle notation got duplicated here, and triple got duplicated. Double and triple, they were 45 degrees. They got duplicated, so it became 90 degrees here too. Okay, any other thing we know? This is straight angle, so we can just consider it to be straight. Oh well, then we got that far. So let's make now let's see if we can see it more clearly.